Welcome to our deep dive into Zelio Regulation Modules. These modules have been a game changer for many, especially given the limited resources available for Zelio devices. The file you're looking for is called Regulatory ZM2. It's a crucial component for enhancing your Zelio system's capabilities. To access it, navigate to the Upload section on the forum. Click on Altri Argumenti at the top right, then select Up/Download Files. From there, go to PLC, then Schneider, and finally, you'll find Regulatory ZM2. Remember, to download any file, you need to register and log in. Once logged in, the download arrow will appear, allowing you to get the file. This module is a testament to community-driven innovation, where sharing solutions benefits everyone. Imagine a PLpedia, a library of shared knowledge, growing with every contribution. This is the spirit we embrace here. Understanding the theoretical basis of Zelio regulation is crucial for mastering its application. At its core, Zelio regulation operates on a feedback loop mechanism. Imagine a thermostat in your home. It constantly checks the room temperature against a set point and adjusts the heating or cooling accordingly. Similarly, Zelio regulation modules monitor input signals, compare them to desired set points, and adjust outputs to maintain stability. The key parameters here are the proportional, integral, and derivative settings, often abbreviated as PID. These settings fine-tune the response of the system to changes, ensuring optimal performance. For instance, setting the proportional gain too high can lead to overshooting, while a low gain may result in sluggish response. Integral action helps eliminate steady-state error, and derivative action anticipates future changes, smoothing out the response. Remember, the exact values for these parameters depend on the specific application and the dynamics of the system you're regulating. To begin the configuration of Zelio regulation modules, you need to navigate through the software interface. First, ensure that you have downloaded their Regulatory ZM2 file from the designated Upload section. Once downloaded, open your Zelio software and go to the Modules tab. Here, you will find an option to add new module. Select this and browse to the location where you saved Regulatory ZM2. Load the module and proceed to the configuration panel. Here, you'll need to set specific parameters. For instance, adjust the timeout parameter to 500 milliseconds for optimal performance. Also, ensure that the communication port is set to the correct value, typically COM1 or COM2, depending on your system setup. Remember, precise configuration is crucial for the module to function correctly. And here's why that matters. Incorrect settings can lead to communication errors or module malfunction, which we'll troubleshoot in the next segment. Now, let's dive into the execution and coding logic required for the Zelio regulation modules. First, you need to understand the function blocks within the Regulatory ZM2 file. Each block corresponds to a specific regulation task. To execute a function, you'll typically start by initializing the block with the necessary parameters. For instance, if you're working with a PID controller, you'll set the proportional, integral, and derivative gains. These values are crucial. They determine how the controller responds to input changes. Remember, the default values might not suit your application, so fine-tuning is often necessary. Additionally, ensure that your input and output signals are correctly mapped to the block's variables. This mapping is done in the configuration section of your Zelio software. Misconfiguration here can lead to erratic behavior or even system failure. So, pay close attention to these details. Now, let's dive into some advanced tips to optimize your Zelio regulation modules. First, ensure you're utilizing the latest firmware version to take advantage of performance improvements and bug fixes. Next, fine-tune the PID parameters for your specific application. Start with a proportional gain of 2, integral time of 100 seconds, and derivative time of 10 seconds, then adjust based on your system's response. Remember, a higher proportional gain increases sensitivity, while a longer integral time reduces steady-state error. For those dealing with noisy signals, increase the derivative time to smooth out fluctuations. And here's a pro tip: enable the anti-windup feature to prevent integrator saturation during large setpoint changes. This leads us to the importance of regular maintenance. Check your module's calibration periodically and recalibrate if necessary to maintain accuracy. Lastly, engage with the community. Share your configurations and learn from others' experiences to continually improve your setup. Now, let's dive into some common pitfalls you might encounter when working with Zelio modules and how to debug them effectively. One frequent issue is improper configuration of the communication settings. Ensure your baud rate is set correctly. For most Zelio applications, 9600 baud is standard. Another common mistake is neglecting to check the power supply. Zelio modules require a stable 24 volts DC input. Any fluctuation can cause erratic behavior. When debugging, start by verifying the physical connections. Loose or corroded wires are often the culprits. Use a multimeter to confirm voltage levels and signal integrity. If you encounter error code 0x12, it typically indicates a timing issue. Adjusting the delay parameters can resolve this. Remember, meticulous documentation of your setup and changes can save hours of troubleshooting. Keep a log of every modification you make. To master the Zelio Regulation Modules, remember these critical steps. First, understand the architecture. Zelio's limited resources require efficient coding. Second, navigate to the correct download section, Altri Argomenti, then /download files, followed by PLC and Schneider. Third, ensure you're logged in to access the regulatory ZM2 file. Fourth, utilize community resources, share and download files to build a collective knowledge base. Fifth, apply the modules practically, configure settings, test functionality, and troubleshoot any issues. This collaborative approach not only enhances your skills but also contributes to a growing repository of knowledge. Subscribe to stay updated with more in-depth tutorials and join a community that values free education and shared expertise.